Hello, and today we're going to be talking about hexadecimals. Okay, so before we get into hexadecimal, let's talk about a review really fast for a bit versus a byte. So a bit is a 0 or a 1, if you remember from the binary example, and that's going to be one digit is 1 byte, bit, 1 bit. And now let's talk about what a byte is. And if you don't know, a byte, or if you do this review, a byte is 8 bits. So bits and bytes, everything's binary is typically represented in groups of 4. So a byte would be 8 bits, which is 2 groups of 4. So that would be 0, 0, 1, 0, 1, 1, 0, 0. It doesn't matter what each bit is. The point is it's 8 bits total. So that's what a byte is. So when we get to these really large binary numbers, you have a lot of zeros and ones, and that's really complicated. So that's why we bring in hexadecimal. Now, hexadecimal is really useful because hexadecimal is something that's much easier for humans, and it's a way to break down large binary numbers. So you have a really large number, and you break it into 4s, and then you have your bytes, and each one is a bit. Like that's a lot to remember, and it's really hard for humans to easily comprehend that. So that's why we introduce hexadecimal. Now, here we have a table showing hexadecimal. Hexadecimal is, you can think of it as 0 to 9 as normal decimal numbers, and then we go from 9 to 15, so 10 to 15 is going to be letters instead of numbers. So that means that once we get to a 2-digit number, like 10, 11, 12, so on, we can just represent that as A, B, C, D, E, F. So this makes it really easy to understand and see large binary numbers. So here we have an example. You can see that it's already broken up with spaces, right? So we already have it in groups of 4. And the nice, convenient thing about this is that hexadecimal, as you can see here on the table, also represented by 4 bits, right? So binary, all of these is 4 bits. So let's do an example here where we break down this binary number, this 16-bit binary number, and we're going to change this into hex. So let's start with the very first one. So we've got 1, 1, 0, 0. Now, if you want, you can do some practice and see how good you are at conversion from binary to decimal. If not, you can just swipe back over to our handy dandy little chart, and you can see that 1100 is 12 in decimal, aka C in hex. So that's going to be C. Right, so now we have 0, 0, 1, 0. That's going to be, you can do this quickly off the top of your head if you want. That's going to be 2. And so if we remember that hex is 0 to 9 normal, and then 10 to 15 alphabet. So this is going to be 2, right? So that's just going to stay as 2. Now we've got 0, 1, 1, 0. Look over here, 0, 1, 1, 0, right here. That's going to be 6. So we leave that as 6. And our last one is 0, 1, 0, 1, which is right here, and that's 5. So if you want to change this very large binary number into hexadecimal, it equals C265. Now, the other nice thing about this is that not only as humans is this easier for us to read, we can read it out, it's just 4 digits, 4 alphabet, letters. It's much easier for humans, but that's also representing 16 bits with 4 digits. So that's huge, and that's the whole reason why we have the hexadecimal, is it's much easier to understand, and you get a much bigger range with 1 digit. That's all. Thanks. Now for hexadecimal, we can also write it as, so if we go to our previous example, that was C265, so C265. Now the notation for hexadecimal is typically seen as 0x, and then the hexadecimal number. So again, that's 0x before the hexadecimal. And obviously, you can also always just write you can also just always add hexadecimal at the end, but 0x is the correct notation.